Now, another interesting example, I think this is really motivating. And this is showing, given a video, of course, as a human, we can watch the video and we can infer a lot of things about it, like what action is happening or what different objects are present in the video. So a lot of those things. But again, as images, it's very challenging to actually do inference on videos, because first of all, like, it's very complicated, right? It's more complex than video. We have this additional dimension of time. Okay, so let me show you like one very simple representation of videos. And so, for example, this is called like point light displays. And what we do here is, let's say we have a human, a person performing some action. We just identify the joint angles, okay? The joint angles of like the human skeleton. And these white dots on the right are exactly showing that. So this was like a very dense image, right? You have this person. It's a lot of information here. But what all we are interested in is just these joint angles. And you can think about like this image will require a lot of memory to save these pixel values. But if you just store these joint angles, it's like just 2 points, like X and Y points for each joint angle. So even if you're storing all the 25 joint angles of human skeleton, you only need 50 numbers. Okay, so that's pretty compressed format as if you compare that with the original image. And this is like another example. Now let's have a look like how this is pretty useful. And of course you can use this for like a lot of other applications. I will just show you like for action recognition. And of course you can use for facial recognition, sign language, and all of those. Of course, the key points will be different there. Okay, so now look at this. So in this case, I'm not showing you any colors, right? It's just black and white image. And what I have done is I've just tried to connect like those joint angles. So it's a very compressed format. And if you look at this, you can say that, okay, a person is walking. It's pretty easy for us. If I compress it further, let's say I don't show you like the connected joint angles. I show you just the joints. Okay, so you can, it's hard. You might not be able to say what's happening there. But if you have some kind of prior knowledge that, okay, you are looking at a person who is walking, then you can guess, okay, it seems like a person is walking. And we can make it denser. And then it becomes more, it's easier, right, as compared to the center one. Now, as a human as well, like it's easy for us, and it's interesting because it's actually solving two purposes. The first is it's actually compressing the amount of memory you require to save your data, right? And the second is it's like a very compressed format of your action, what is happening in your input video. And it will be a lot easier for your computer vision algorithm to determine like what action is happening in this scene, as compared to by looking at like the full RGB image. Okay, so this is one example of how you can represent or how you can extract features from your videos. And it's a very compressed format.